Report on this computer. Okay, so it is Thursday, November 17th. We're starting science lesson 6.04, forces of motion. It's 17 pages long, so it's long, but you have 4 days to do it. It's not due till next Tuesday before you leave for break. So we'll go through part of it right now. And then if you want to go work in a breakout room and do it with a friend, the breakout rooms are open for that as well. You've heard the story of the 3 little pigs, right? One built his house of straw, another built his house out of sticks, the last one built his house with bricks. Did you know, however, that the wolf in the story would need to huff and puff a gust of breath over 130 miles per hour to blow the brick house down? Whew. Let's learn more about how force on objects creates motion. I wonder how much force he had to use for the stick house. I will be able to investigate and describe that the stronger the force applied to an object, the greater the change in motion of the object. I will be able to plan and carry out fair tests in which variables are controlled and failure points are considered. And third, I'll identify features of a model or prototype that can be improved, which is part of the engineering process. You guys do that all the time, although we haven't really ever done a second prototype of an object. Strong and weak forces. Forces are used to create motion. The distance an object moves depends on the force that is applied to it. A stronger force will result in a different motion than a weaker force. Look at the ant in the picture. The ant is using a pushing force to move the rock. If the ant used a stronger force, how do you think it would change the motion of the rock? How do different forces change motion? Rock might fly across the room, huh? Observe this short video clip. How would the motion of the tennis ball change if you used a stronger force to move it? Let's take a look. Oh, it just barely rolled across the thing. So what do you guys think? How would the motion change if you hit that harder, like with a tennis racket? Christian, what do you think?
It would go faster?
Yeah, it would go a lot faster, huh? Might bounce off the page. The stronger the force applied to the tennis ball, the greater the change in the motion of the tennis ball. The change in the motion of the tennis ball would cause the tennis ball to travel further and faster. Think about a situation where cars run out of gas. You and the people you're with would have to push the car along a paved road to the next closest gas station. A friendly group of people come by and offer to help your family push the car. Do you think the car will get to the gas station faster or slower? What do you think? Thumbs up faster, thumbs down slower. Yeah, let's check. The car would likely get to the gas station more quickly. Having more people push the vehicle means more force is applied. The more force applied means the greater the change in motion. Practice like a scientist. In this activity, you'll explore forces and motion. The checklist below will provide you with tasks to complete as you explore the interactive. Use the checklist to explore how different pushes and pulls can affect the change in motion of an object. Push the car with a weak push the car with a strong push, pull the car with a weak pull the car with a strong pull. Let's see if it works. This looks fun. Okay, here we go. Go. Oh, here you can adjust your push. Let's start with a strong. Use a stronger push. Let's do a strong push first. Here we go. Go. Where's the car? Oh, wow. We're cruising. Oh, there's the car. Reset. Let's try it again. Let's pull the car. Oh, let's do it with a weak push. Go. Uh-oh, it's not even moving. We better give it some push. There, just a little bit. Didn't go very far, did it? What do you want to do now? Should we pull it with a strong pull? Yeah, and you guys can play with this too. This is kind of fun. This is on page 2. Okay, here we go. Let's watch it. Go. Oh, it's got a magnet. That's great. Oh, it made it to 4. Now let's just go a little bit. What if you do both of them, pushing and pulling? Oh, that goes the furthest of all. Oh, then let's try both. Strong push. How far do you think this one's going to go? Strong pull. Here we go. Wow. That's a long room. It has like 20 beds in it. Look, it went 26 feet. Woohoo. Okay. Let's go to the next page. Changing motion. Baseball is a sport that uses many forces. The force used to hit the ball with the bat is of particular importance. Sometimes a batter hits the ball with a little force, resulting in a bunt. Bunt is when they hold the bat like this and just kind of hit it. Other times, the batter hits the ball with a big force that scores the team a home run. How does changing the force affect the motion of the baseball? Flip each card to learn about how different forces change the motion of an object. Oh, look, here we have pool. Have you guys ever played pool? Any of you ever played pool? Yes, no? Yes? All right, here we go. How does changing the force applied? Oh, look, she's pulling it back further. That gives it more force. Interesting. Share with a friend or family member a time when you observed that the stronger the force applied to an object, the greater the change in motion of the object. Who has a story of a time that you've hit something with a little bit of force and then a lot of force? Can you think of any time you did that? Have you ever done a, like anything where you pulled back on a rubber band and shot something? Have you ever tried that? Or a cat toy? Or a tennis ball? You hit it a little bit, you hit it really hard.
I've done a rubber band.
Yeah.
Yeah.
Have you ever tried to, we used to love to play this game where we tried to hit a ball over our house. So we would use a tennis racket and try to hit the ball over the house. Because if we could make it halfway, it might fall on the roof, but it would roll to the other side. So one person would stand on one side of the house and one on the other. I don't think you could do that at my house now. It's too tall. Liam, go ahead. Did you have something else you were going to say? Are you using some force? Here it says, oh, like, so what about just jumping in the air? Do a little jump and then do a big jump. Let's see somebody try it. Who wants to jump? There you go. Do a little jump and then do a big jump. Don't hit your head though, Christian. All right, a paper airplane. Tomorrow we're going to make an airplane. You could throw it a little bit or you could throw it harder with more force and it will go further. Page 4, blasting off with force. Have you ever watched a rocket blast off into space? Have you ever watched that on TV, guys? I think we just sent an unmanned spacecraft to the moon. Did you know that? Yeah, very cool. What a sight it is. Rockets require a very strong force to get them off the ground to defy gravity. That force must continue in order for the rocket to overcome gravity and go higher and higher in the sky. Then once it breaks out of our gravitational pull, if it gets far enough from Earth, then it gets caught up in a orbit out there in space, and it can keep going for a long time because the gravity isn't exerting much effort on it. Remember, the stronger the force, the greater the change in motion. A strong force will blast the rocket up into the sky, but a super strong force will make it go further into space. Have you guys ever shot off a rocket? When I was a kid, we used to have a rocket club at school and shoot rockets right at school. It was really fun. In this next activity, you'll get to build your very own rocket and investigate how different forces will affect the motion of the rocket. Practice like a scientist. In this activity, you'll explore how to change the motion of a rocket using different forces. Print the Make a Rocket activity sheet and follow part 1 of the procedure, steps 1 through 5. Follow along using the slider below. Okay, so here's the worksheet, Make a Rocket. In this activity, you'll build your own straw rocket and explore how different forces will change the motion of your rocket. How can I change the motion of my rocket using different forces? What do you think will happen if more force is applied to my rocket? The independent or test variable is the force that is applied to the rocket. Everything else is going to be the same. You'll need a rocket template, scissors, tape, pencil, straw, and tape. I'm not sure I have a straw right now, but what you can do is get started building this, and then the next time you go to a place that would have a straw, ask for one of the straws, okay? So we're going to take a look back in the lesson and get started. Make a rocket template. Step 1, using the rocket template, carefully cut out the rectangle. So let's see if we have that in our science book. Take out your science book and let's look in on that page. 6, make a rocket, here it is. And is our rocket template in here? Oh, somebody didn't print the rocket template. I'm so sad. Oh no, here it is. It's in here. Okay. Whew, I'm relieved. Here's our rocket template in the book, and we're going to cut this out. So get your booklets right now and get a pair of scissors, please. Find your booklet, find a pair of scissors. It says, carefully cut out the rectangle. Do you have your booklet, Amadi? Get your booklet. Amadi, have you got your booklet? I'll stop my share for a minute. Here's your booklet, and this is the page we're looking for, guys. Find your booklet. It's on, it's 604. 604. And it's this rocket template. And we're carefully cutting out the rectangle right now. So 604, look in your booklet to page 604 and try to find the template. And then we're going to cut out the rectangle carefully. Okay, I'm going to pause the recorder while we're cutting. Okay, so now we've wrapped our paper around our pencil, and step 2, cut out the fins. So we're cutting out the fins. We got 2 of those to get cut out. Nice. I'm going to make another one and resume the recording. We're going on to step 3. So step 1, we take the paper around. Step 2, we just use the pencil to make the tube. So you can take the pencil out, or in this case, they've kept the pencil in. I don't know if it matters. Carefully cut the 2 fins, each one to one end of the rocket body. Be careful not to let anything stick out past the body tube. Do the same thing for the other fin unit. Tape it to the other side of the pencil so you have a thin sandwich. So what they mean is make sure that your, there comes my pencil. Make sure that your tube, is not got this after it. You need to make sure that it's like that. And then you're going to tape that on.
So like this, like this?
You want to make sure that it doesn't, like this doesn't stick below. You've got to have this here. So not too high, but not too low, like about there. And then you're going to tape the bottom and the top of it on to make sure that it stays.
Mayday, 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 mayday,
A lot of
mayday.
maydaying going on over there. Okay, so I'm taping on the top part of my fin, one fin. And then you have to have like 4 pieces of tape or sticker for this, Amadi. What is that?
What was that?
That was a scream. With
You
the rebel
still
yell.
have a problem. The wing was damaged.
I think you can fold your wings a little bit too to make them flat. So there's one. Now I gotta glue the other one, or I gotta get the other one on. Yeah, there you go.
Where do I put the wing?
Now 2 more, Amadi. Oh, you know what, Amadi? I think that you rolled your paper hamburger, not hot. Oh, there it is. Oh, perfect. I thought that other one was your paper. Okay. So you put them on like a sandwich. So you put the first one on, and then you put the other one on the other side of the thing, but just like a sandwich, they're just exactly in the same places. One's on one side of the rocket, and one is on the other side of the rocket.
Whew, mayday.
It's a lot of work, isn't it? Boy, you say mayday a lot, kiddo.
I don't know. The space mood, actually.
You're in a space mood, so you say mayday.
I'm kind of in the space and the December mood.
Space in December, huh? Well, at least you're not stuck on Disneyland still.
Huh?
So now you should have them on top of each other like that. So there's one on the top and one on the bottom. Give it a slap.
Ow.
How are you doing, Bree? You doing okay?
So hard.
Okay. All
This
right.
is so hard. I have to get this one.
Okay. We're gonna go on to step 3. I know you're not all there, but I want to keep going because otherwise we're gonna run out of time. We only have 2 more minutes before book club starts. Step 3, bend one fin on each unit 90 degrees. So each fin is at a right angle. Can you see that down there? So if I'm looking at this, you can see that they all stick out at right angles. So with my rocket, I'm gonna fold this one like this. And then fold this one like this. You really just have to bend 2 of them. The other 2 can stay where they are, but you want your fins to come out like this with them all at 90 degrees, like that, right? Let's see what else happens next.
Damage to my wings.
Fin should make a plus sign if you look down on it, or like an X. And finally, use the sharpened end of your pencil, twist it to form a tip. So what they mean by that is you're going to take the pencil, put it back in if you can. I don't know if I can actually, but they wanted you to use it to make this into a tip. My pencil fell out and I don't think I can get it back in, so I'm not going to be able to do it, but hopefully you guys can do it. Oh, maybe it's going back in. I can't tell. Oh yeah, there we go. If you have your pencil still in there, rocket, and you can take the tip and make it like a pointy tip. You can kind of push it around your pencil to make it pointy. Mine is not coming out too pointy, but oh well.
It's book clubs.
It is book clubs, but there's the pointy tip on our rocket.
Here's mine.
Okay, this whole direction is on page, let's see, page 4 of our lesson, and we'll continue with it again tomorrow afternoon. Okay, so I will see you guys to finish the rockets tomorrow afternoon. Don't worry, you won't miss anything. Just put it somewhere safe where you won't lose it, and we'll continue with that next time.
Yay.
Meantime,
I'm going to go into room 1.
yeah, let's send everybody into room 1. So
Okay.
Amadi, Liam, I'll send a note to Pamela. Don't worry, we won't keep doing the rocket right now, Amadi. Okay, Amadi, can you go to room 1? I don't know if I even have it. There it is, room 1. Okay, Liam, Amadi. Okay, head to room 1, Amadi.